Lesson 16 of Calculus. We're now using what we know about how to find a derivative with mathematical applications. All right, the first one in section 1 is finding extrema on an interval. So the extreme value theorem says if f is continuous on a closed interval AB, then f has both a minimum and a maximum. The key is that it's a closed interval. So maybe the max or the min might be at one of the endpoints. So not necessarily in between, but obviously since you have an endpoint, one of the endpoints is going to have to be a max or min if there's isn't one in between them. So here's the first example that we're looking at. It says f has a relative max at 0, 0, and it has a relative minimum at 2, -4 down here. So again, a max is like at the top of the hill, and a minimum is at the bottom of a valley. And we learned that in pre-calculus. This equation is x to the third minus 3x squared. If you can't read that, put it in the calculator already for us. So y equals x to the third minus 3x squared. So graph. So you can see the max there and the min there. And what you learned in pre-calculus was to do second calculate the max, and you'd pick a point to the left of it. Then you'd go over the hill, hit enter, and then you'd have the max down here. That means 0. Remember, when it's a really small number, e to the -6, that's 0. So 0, comma, -6.333 to the -12, so that's also 0. Anyway, the max is at 0, 0. And then over here is the minimum. Let's do that one. So second, calculate the minimum. So pick a point to the left, then go to the right, hit enter, enter, and it has the minimum at 2, -4. So the calculator behaved on that one and told us what the minimum was, unlike the max, which was at 0, 0. It gave us a crazy small number, which meant 0, 0. Anyway, that's what we did in pre-calculus. We used the calculator to do it. But you can find it mathematically. So if that's f of x, what we're going to learn here by the definition of a critical number and on the next page is that you take the derivative of it. So the derivative of that is 3x squared minus 6x. So f prime is equal to that. And then what we want to know, at these points here, at the max and the min, the slope is equal to 0. And remember, when you take the derivative, it's all about what the slope is at the curve at any point in time. So if we can find where the curve is equal to 0, then we know where we have a max or a min. So what we want to do is take the first derivative, and then what we want to do is set it equal to 0. And wherever that derivative is equal to 0, or wherever that slope, this is the slope of this curve now at any point in time. So wherever that's equal to 0, you're going to have a max or a minimum. So I'm going to factor out an x. These next few sections are all about factoring. So if you factor it out, and just like you did in pre-calculus, to solve the equation, you factored it in when it was set equal to 0. And by the zero product property, then you set each one of the factors equal to 0. So you get 0, and over here you get x is equal to 2, which is what they had. And then you do, you take those critical numbers. This is called a critical number, and that one's a critical number. It's where the graph has a slope equal to 0 by the first derivative. And then you take those critical numbers and you plug them back up into the original equation to find where those points are at, where that max and where the min is at. So if you did f of 0, you would get 0. And if you did f of 2 and put 2 into it, you get -4. So it's the same thing you've learned from pre-calculus. You can do it now without using your calculator if you wanted to. So here's the first definition. Let f be defined at C if f prime of C is equal to 0, or if f is not differentiable at C, then it's a critical number of f. So that's important. It goes here through the next few sections, the thoughts about what a critical number is. A critical number is, again, when the first derivative is equal to 0, or where it's undefined at the first derivative. So again, the first derivative is 0 when the slope is equal to 0. It's going to be a max or a min. Or if it comes to a point, or possibly there's not even a point there, if there is no c, then it doesn't exist and you can't find what f of c is. So it has to exist. All right, so on the next page, it gives us some guidelines here for finding extrema on a closed interval. To find the extrema on a continuous function f on a closed interval ab, use these steps. Find the critical numbers of f in ab. Again, that's where the derivative is equal to 0, r, where the derivative is undefined. And then it says evaluate f at each one of the critical numbers in AB, evaluate f at each endpoint of AB. So we got to find the critical numbers and we're going to use the endpoints. At least one of these values is a minimum. The greatest is the maximum. All right, so let's do a problem with it. So it said the first thing we should need to do is find the critical numbers. So to do that, we're going to need to take the derivative. So we have 7x squared plus 1. So the derivative of that is 14x, which was a pretty easy derivative to take, I know. But again, according to the guidelines of above, we want to find the critical numbers. So we want to take that derivative, set it equal to the 0. And of course, all we're going to do is get 0. And so our critical numbers are x equal to 0. And also we want to use the endpoints, which are negative 1 and 2. And then to figure out which one of those points in that closed interval are the max and the min, then we have to do f of those numbers, so f of c. So looking at f of c for all of those numbers, so f of 0, and we want to do f of negative 1, f of 2. So the original function was 7x squared plus 1. So if you put 0 in there, you get 7 times 0 plus 1, which is 1, and then 7 times negative 1 squared plus 1, which gives you 8, and then 7 times 2 squared plus 1. So 4 times 7, 28, plus 1, 29. So this one's going to be the max, and that's the smallest number, 1. We have 1, 8, and 29. 29 is the biggest, so the max value is 29, and the min value, or you could say it's the relative min. We don't know if it's the absolute max or absolute min. So it's a relative min and a relative max. So the relative min on that interval is 1. So I'm going to say here we have the point 0, 1 is the minimum. And then 2, 29 is the maximum. Okay, on the next one, we have an absolute value, which kind of brings up a new derivative rule that we really haven't done before. So the derivative of an absolute value. So if you're taking the derivative of the absolute value, we'll say of u, the derivative of that is u over the absolute value of u. So just like when we do the derivative of the sine x, it's the cosine of x. This isn't just the derivative of just x or just u. It's the derivative of x plus 4. It still comes out pretty clean, but you got to treat that like it's a u. So the u here would be x plus 4. So the derivative of that, g of x, g prime of x, is u on the top, which is x plus 4, over the absolute value of u, and then times the derivative of u. And luckily the derivative of x plus 4 is just 1, so it's times 1. So it's a little bit of the chain rule going on it. So the critical numbers on here, there's really not that many, and the critical number would obviously be the number negative 4. It's whatever makes the top equal to 0 or the denominator undefined, which is the same number, negative 4. So if x plus 4 was equal to 0, x would be negative 4. So the critical numbers here are C are negative 4, and then the endpoints, negative 7 and 1. So again, you have to do f of negative 4, and you have to do f of negative 7, and then f of 1. Back into the original problem, back into the original f. So the absolute value of x plus 4 was what it was. So absolute value of negative 4 plus 4 is 0. Absolute value of negative 7 plus 4 is 3. And the absolute value of 1 plus 4 is 5. So we've had the minimum here, that's the smallest number, and here's the max. So negative 4, 0 is the minimum. And then 1, 5 would be the max. All right, so that's all of 3.1 about Extrema. And again, you can find them on your calculator, but they're going to want you on your tests and your quizzes to show it using calculus. They don't want to say, they don't want you to write, I found it in my calculator. No, you're supposed to find it using calculus. So you have to find the derivative and find the critical numbers and plug them back in for f. All right, see you for the next lesson.